Bismillahirrahmanirrahim. Okay guys, Assalamualaikum warahmatullahi wabarakatuh. So here are the laboratory module 1 on the characteristic of DC series and DC shunt machine. Okay, now I'm recording the briefing on how you want to conduct this experiment, and later on if you have any kind of question or concern, you may ask on your PIC lab in charge. Okay, for this part and onwards, we have decide that you all have to perform the experiment and reports in group, such that you can discuss between your group mates to have a further understanding, and later on you can submit the report by group. So 3 of the names that listed inside your group, you can represent 1 person to submit the reports. Okay, as for this experiment, the objective is that when you have finished performing this experiment, you should be able to compose, simulate, and analyze the performance and characterization. Perform the characterization of the shunt and also the series connected motor using sim simulation tools. Okay, as you will learn, or you should be read prior to this experiment regarding DC shunt and DC series motor. As we all know that DC shunt motor, also known as a shunt wound DC motor, where the field windings are shunted or connected in parallel with the armature winding. So we have an armature winding. So the magnetizing coils is connected in parallel with the armature. Okay. Meanwhile, in the series connected, the field windings is connected in series. So the two arrangement differentiate between these two kind of motor. So what we are going to perform inside our experiment now is that we want to differentiate in terms of performance and characteristic of these two motors. So in general, we can classify the DC shunt motor compared to DC series in terms of control methods. They are performed in kind of two ways or two methods. One is that we control the armature throughout the armature adjustment, control throughout the armature adjustment of the parameters, and another one is on the field control methods. Meanwhile, the characterization and the performance of the motor can be seen throughout the trend that we plot on the adjustment or on the speed armature current characteristic or the torque armature current characteristic. And meanwhile, the speed torque characteristic we plot after we plot the two first parameters changes. So all of this behavior or characteristic of this motor you will perform and you will present throughout your PSIM simulation throughout this experiment. First, you will conduct the experiment for DC shunt motor. Okay. If you refer to example 8.1, we will actually produce the same calculated in the example throughout simulation. So we will take the same parameters in page 472 of example 8.1, and you shall reproduce the schematic in PSIM to simulate the response of the system. So by right, this is the basic generic circuit schematics that you should draw or sketch inside your PSIM simulation software. First of all, you put in or place the source of DC source, and you put and connect the connection of your DC shunt motor, and then you connect your mechanical to electrical interface block like this. Because we shall and after the interface block, we put in the load resistor, because we shall plot the trend of how the motor behave when we adjust the armature current. But for sure the armature current cannot induce, or we cannot push in from the source. We have to put a load to the motor. That's how when we have a load, the motor itself will draw current from the motor. Then the motor will draw current from the armature and from the source. So we need to put this kind of load resistor source, and we shall adjust the load resistor impedance, or the load resistor resistance, so that the current will vary, the armature current will vary. So once you put or draw your circuit, and you put all together the ammeter and voltmeter inside the circuit, then you need to adjust the DC machine parameter to follow example 8.1 in 472 pages of your textbook. Okay, you adjust the armature value, field resistor value, rated voltage, also to refer or to follow the same per example 8.1. Then you use, what I mentioned before, the mechanical to electrical interface block, and connect to the grounded resistor of the load as the load of the system. Then for within this machine, you shall vary the armature current to observe the response of the speed and torque of the motor, so that the load resistor need to be adjusted accordingly. So you may use the value of the range from 15 ohm down to 0.2 ohm to see what are the response or the trend of the graph. Okay, so you set this 6 data points in between this value, 15 maybe, 15, 10, 8 like that, down to 0.2 ohm. So in the simulation control box, simulation control time, you set your circuit to simulate in 5 second time, 5 second time duration. So you run the experiment, and before that you compose a table, you run experiment, and you publish the table of all the 6 data points. Means that you repeat the same experiment or simulation for 6 times at least. Then from the graph, from the table that you generate, you put inside Excel and plot, then discuss the trend of the speed armature current behavior or characteristic, the torque armature current characteristic, and also the speed torque characteristic. In general, what you should observe from the graph is that for the DC shunt motor, when we increase armature current, or when we adjust on the load resistor value, the armature current will increase. At the same time, the torque also will measure as increase. And more current you supply, or more current it draws, so more torque it produces. And in terms of speed, you can see that the shaft speed will reduce, and when you increase armature current, it will reduce, but not so obvious in terms of production. This is the special thing about DC shunt motor. The speed will be much constant all the time when you add up load to the system. And then you plot the speed torque response, so you should be able to get the result, some sort like this kind of result. Okay, Then in terms of speed control of the DC shunt motor, okay, you need to produce another, we shall control the motor inside the simulation throughout the reduction of your field resistance, field resistor. So inside your RF here, you put another 3 reduced value. Maybe you want to reduce down to 10%, minus 10% or minus another 30%, 50%, it's up to you. So you plot another graph of speed torque to have a look on how the behavior of the motor when you reduce or you adjust the field resistor. Then you plot and compare the curves on the same screen. Okay. All the speed torque that you generate from G here, you plot on the same screen and give a comment. And then you repeat the same thing on the DC series motor. Just that you will change the connection of shunt connection system into series. So from the terminal of negative terminal of your motor, connect to field resistor and back to source. All other settings are the same. But inside the DC parameter motor box, please include, because this one we copy the example inside the textbook as well, from page 497, example 8.5. So the data of your DC machine should be like this. So total R armature plus R field will be 0.08. Your rated current of armature will be the same as rated current of field, because they are sharing the same line. Okay. Okay, use the mechanical electrical interface block as well and connect to the ground resistor. But at this time, you shall simulate at least 6 data points with a range of 1000 ohm down to 0.1 ohm. So you can see the trend. So same like DC shunt, you simulate in 5-second time cycle setting. So you create a table and publish all the data inside the table. Then you plot the same characteristic of speed torque, speed armature current behavior, torque armature current behavior, and speed torque characteristic. And for this DC series, we only apply voltage control method for speed to control the DC series motor, to control the speed of the DC series motor lah. So you need to reduce to another 3 values of V terminal and repeat also, again the step D here. We simulate from the same data and you paste and comment on the same screen, on the graph on the same screen. Okay, then you discuss and conclude your overall experiment. First, you compare between DC shunt and DC series in terms of the performance. Then you conclude the overall conclusion of your experiment that you done inside this experiment. Okay, by right, the result that you should get from, or the response you should get from the simulation is like this. So you can combine in terms of I field, I armature, and I input on the same graph, then the speed torque on the same graph. And some of you asking on how to generate or calculate power. So you don't have to calculate actually power on this sim. You just need to put equation of I input times V terminal. This is for input power. Then you paste also here the output power, which is V out times I out. Okay. Okay, good luck for your experiment, and submission is 1 week before you start the next experiment. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.